Right, so this lesson is about M2 Mechanics Year 2, Chapter 4.3, about equilibrium. So first of all, I forgot to leave some space for the notes, so please find somewhere to write down, okay? First of all, we do have to understand what's equilibrium. Equilibrium, if you look in economics, it means you're not making a loss, break even. But in mechanics, when a body, you might write down, when a body is in equilibrium, I thought I would spare you with my horrible writing, so I'll just type it up. The resultant force and the moment of the body on the body is zero. It means it's not moving. The particle is not moving. So particle is equilibrium, it means not moving. So if it's not moving, that means all the force, the resultant force and the moment on that is zero. So we'll do two calculations on it. Okay, so resultant force equals 0 Newton, and the other calculation is resultant moment equals 0. Now we're going to focus on these 2 points to do our calculation. Okay, so the first point, resultant force equals 0, and resultant moment equals 0 is the second point. So let's have a look in the first example. Diagram shows a uniform rod AB. Think of it like a seesaw, but a different one. But maybe, actually, think about these are 2 supports. You put a plank on there, so we're supported, of length 3 meters and weight 20 Newton. A uniform rod means the weight is right in the middle. So I tend to like to draw my own diagram because I have so much confidence in my drawing that I think it's better than the diagram one. You think I'm kidding? Of course I'm not. So 2 meters, 1 meters. I'm going to call this A, C, and B. Now, I'm going to use different color for the weight. Okay, for any force, 20 Newton is going to be right in the middle. In total, that's 3 meters. Therefore, the weight is going to be right in the middle in here. Sorry, I just disrupted by someone else. Right, anyway, so we were saying the weight is right in the middle. Next, what else? They're resting horizontally on the supports A and C. When a plank or something is resting on a particle or something, you generate reaction force. Now think about this: a person, okay, you, me, right, standing on the ground, okay. Now I know probably people will be quite embarrassed to say the weight. I'm going to tell you mine. Mine's 65 kilogram. So when I'm 65 kilogram, I'm exerting 65 times gravity, 65 G of Newton to the ground, right? Now, in return, the fact that I'm standing on the ground still and not moving, not sinking, that's because the ground is returning the same support force to my body. So the force, okay, is that the ground is returning a 65 G of reaction to me. This is the reaction force. So same in here. The plank, okay, is 20 Newton. The fact that the plank is resting on these 2 supports but not collapsing, that's because supports A and C are providing altogether the 20 Newton of support. So to write this, to notate the support force, we're going to use RA and RC. That means reaction from A and reaction from C. One will be thinking, why are they not both 10 Newtons then? Because if the total is 20 Newton, why are they not 10 Newtons? That's because the whole thing is not balanced, it's not symmetrical. Does it make sense? Yeah, if C is in here, then yes, then RA and RC would be 10 Newtons each. But the fact that C is not in the same symmetrical position as A, therefore A and C would not be the same force as supporting 20 Newton. So, right. Next, yeah. So these are all the forces, 3 forces. Calculate the magnitude of the reaction at each of the supports. So first of all, draw a diagram, and then once you put in all the forces, we can do some calculation. First step, resultant force equals 0. So first step, resultant force equals 0. So what does that mean? That means the upward force equals downward force. The upward force equals downward force. Because surely, if it's not moving, then the force pointing upwards should be the same as pointing downwards. Why? If the pulling force, 20 newtons, bigger than the support force, then that means the supports are not strong enough to withstand the plank. So the plank will just collapse. Right, so 20 Newton would be equal to RA plus RC. So RA plus RC, the upward force, equals 20 Newton. So that's the first step. Second step, resultant moment equals 0. So resultant moment. How do you calculate resultant moment again? Hopefully you've done this in previous video. To calculate the resultant moment, you will need to work out the moment of each force. RA, RC, and 20. So we're going to do that. Okay, so step 2, we'll take moment at a point. Now, there's no pivot in there. They don't tell you which one is pivot. So you can take moments at any point. Now, we'll take moments at A for this instance. The reason you want to take moments at A is because, now, imagine A is a hinge, okay? RA is the force that is on the hinge. Imagine you're opening the door right on the hinge. Can you generate any moment? You can't, because that's the door, that's the hinge. If you try to open it here, no matter how hard you try to open it, you generate no moment at all. Therefore, the moment generated by RA is 0. Now, RA is not 0 Newton. It's just the fact that RA generates 0 moment. For example, when you try to open the door, it's not that you are not generating force. The force that you generate is just not making the door turn. Does that make sense? So when you take moment at RA, you can ignore RA in this calculation, in here, in this calculation for part B, for question 2, for part 2. So we'll just ignore RA. So we have only got 2 forces to calculate moments. We've got RC and we've got 20 Newton. So moment equals the force RC times the distance. So I also need to put distance. That's 1.5 meters in it, because halfway through that will be 0.5 meters. So the distance from RC from the point A is 2 newtons. 2 meters. 2 meters. 2 meters. So equals 2 RC. The unit will be Newton meters, obviously. Direction. That's the door. RC is pushing upwards. That's the hinge at A. When you push it that way, the door is going to rotate that way, which is anti-clockwise. So 20 Newton moments equals the force 20 times the distance from 20 to C is 0.5. 20 times 0.5 is 10. So 10 Newton meters. Distance, direction. I keep missing the word, sorry, my English. If you think about the distance as the door, which is here. Oh, actually, my bad. This is not 0.5, sorry, I took the wrong pivot. The pivot is A, so therefore the distance will be 1.5 meters, my bad, which is 30 Newton meters. And that's 1.5. That's the distance, 1.5. That's the door. When you push it down, the door is going to rotate that way, which is clockwise. So therefore, very happy people, you have to go. Therefore, the resultant moment, which is sum of clockwise moments equals sum of anti-clockwise. Now, why are they equal? You'll be thinking they're equal because equilibrium, because of equilibrium. Equilibrium means the clockwise moments and the anti-clockwise moments should be equal. Otherwise, the door or any object we're moving will be turning, right? So back in again, the year 7 pushing the year 8s, the door, like here, talk about previously, here, yep. Remember this? When 2 sides of people pushing, if ultimately the door in the middle and here is not moving, that means both sides are generating the same moment so that the door is not moving. If any of one side generate more moments than the other, then surely the door would go on the other side, follow the bigger side of the larger moment that generates, right? So that's why, in this case, because they're equilibrium, it means the clockwise moments and anti-clockwise moments are equal. So the sum of clockwise is 2 RC. The sum of anti-clockwise is 30. So RC equals 15 newtons. So if RC equals 15, sub it back into 1, sub into equation 1, then RA plus 15 equals 20. RA equals 5 newtons. And that's how we find the two answers, the two reactions. All right. Now you do a lot of these practice in the exercise, so don't worry. All right. Next one, example number 2. A uniform rod PQ is hinged at point P, so that's the pivot. Okay, that's the pivot. And it's held in equilibrium. Highlight the word equilibrium. Equilibrium means resultant force equals 0 and resultant moment equals 0. Right. At an angle 50 degrees to the horizontal by a force of magnitude F acting perpendicular to the rod at Q. Given that the rod has a length of 3 meters and a mass of 8 kilograms, find the value of F. Now, step 1 about resultant force equals 0. Now, we'll skip this step in here because the rod is not horizontal. So we'll skip this step because rod is not horizontal. Right? So step 2, take moments. Okay, so we're going to take moment at point P because P is a pivot. Right? So how many moments do we calculate? You can answer, even though I can't hear. There'll be 2. F and 8 Newton. So we'll calculate F Newton first for the moment. Moment equals force times distance. The force is F itself. What about a distance? There's a right angle in there. We love it. Therefore, the distance will be exactly what PQ is. PQ is 3 meters. So F times 3, which is 3F. What about direction? Very important. That's the door. That's P is the hinge. You're pushing it left, so the door will rotate anti-clockwise. Also, we need to do HG for the moment. Now, for the HG, it's slightly a bit more trickier. Right, for HG, first of all, moment equals force times distance. The force is obviously HG itself because HG Newton. Now, where's the distance? Distance has to be perpendicular. We don't see a right angle in HG, so we have to make our own perpendicular distance. To make our own perpendicular distance, you must draw a perpendicular line from the pivot. Pivot, pivot, and pivot. So let's do it. Well, so now if you hold your pencil in here on the P, how can you, there's no way you can draw a perpendicular line to 8G because there's no right angle in there. So what you can do is you can make the line long on 8G. So that's your 8G Newton, make it longer. Next, we can do this. That's your right angle. That's your distance. So that's your distance. This distance here is half of PQ, which is 1.5 meters. That's 50 degrees. So using trigonometry, cos 50 equals D over 1.5. So distance equals 1.5 cos 50. I plug in times 1.5 cos 50. Plug in the calculator. I think you will get 75.59 Newton meters. Direction, that's the distance. You push it down, so it will take clockwise. Now, of course, one has to be anti-clockwise, one will have to be clockwise, because the fact that the rod is equilibrium means there must be some anti-clockwise moments and some clockwise moments. Okay, otherwise the rod will not be equilibrium. So next step, clockwise moments. I like to use mums for the for the abbreviation for moments. So clockwise mums and anti-clockwise mums. So 75.59 on the clockwise side. Anti-clockwise representation for mums is 3F. So divide by 3, F equal, if you divide by 3, 25.2 newtons. And that's how we find it. And then more. Yes, just the summary. Right, so a little bit of summary, a small summary. Now, this type of question can appear, not this one, but mainly this type of question, this one here, could appear in the exam. Now, next time we do 4.4, 4.5, we'll just look into different style of this, a different variation of this, but mainly the model doesn't change. The sort of the work that we do, upward force equal downward force, take moments at a point, that doesn't change. All right. Which is adding a bit of variations to the 4.4, 4.5. So summary, if it's not equilibrium, which rarely happens, okay? That's why it's only introduction that it's only not equilibrium. After that, most of the cases will be equilibrium. So if it's not equilibrium, you're gonna label direction of each force on diagram. You're gonna find the moments of each force. So clockwise moments minus anti-clockwise moments. That's how you find resulting moments. But if it's equilibrium, so if not equilibrium means maybe chapter 4.2. Equilibrium is like 4.3 to 4.5. Set the equation, total forces pointing up equal total forces pointing down. Step 2, take moments at a point, choose wisely. Next one, and then you work at the moment of each force about the chosen pivot point. Step 3, sum of the clockwise moments equals sum of the anti-clockwise moments. Okay?